Remember, you need to multiply your coefficients, so it'd be 14, and then add your exponents, so it'd be a to the 7th. You'll see that everybody's happy. There's no negative exponents, so we can go on. If you don't see a coefficient, you can put a 1 right there. So again, multiply your coefficients. 1 times 4 is 4. Add your coefficients. -1 plus -4 is -5. And here we've got a slight issue here. The 4 is fine. You know, it's got an exponent of a 1, but the b's got a negative exponent. So the 4 is going to stay where it's at, and the b we just move downstairs. Here's your final simplified answer right there. For this right here, the coefficient, 6 times 6 will get us 36. The m's would get us m to the -2nd. So again, because we've got that negative exponent, we need to move the m downstairs to make it positive. Right here, don't forget that the n's have 1s for the exponents. So it would be 6 once you multiply your coefficients of 3 and 2, and it'd be n to the 2nd. 8 and 7 would be our coefficients, so multiply them and we'd get 56. Add up our exponents and we'd get 7, so x to the 7th. Everybody's happy there, so it stays the same. And now we get to a new type of problem. It's a power raised to another power here. I'm going to make it just a little bit bigger that we can see it. The idea is that we want to take the outside exponent and multiply all the inside exponents, every single one, including the invisible ones, the ones that are right there. So that would be 2 times 1 would be a 2. So this 4 stays the same there, but this 1, the exponent of that 4, is multiplying this 2, so that got us a 2 there. And this x's exponent of 1, it's 1 exponent. It's going to multiply this exponent here, and that gets us a 2. And of course, we know what 4 to the 2nd power is. That's 16. So it's 16x to the 2nd power. Let's go ahead and do this one right here. Don't forget the 7's exponent of a 1 right here. So we get 7 to the 3rd and v to the 9th. 7 to the 3rd power is 343. And we can leave it just like that. Number 8, pretty much the same thing. We'll get 7 to the 4th power, a to the 16th power, and 7 to the 4th power, I believe, is 2,401. So again, I think 7 to the 4th power is 2,401. You can take your calculator out. And then it's a to the 16th power. So let's take a look at the last two before we get into the last section here. So 9 and 10. It would be 8 to the 2nd power, because this 2 is multiplying the 1 for the exponent. And then 2 times 4 makes that x to the 8th. And that would make it 64 x to the 8th. Now when we get negative exponents involved, we're going to follow the same rules. So -4 times 1 would get us a -4 exponent, and then -4 times -4 would get us a positive exponent. And we're still going to do the same thing that we've always done. You can see that this right here would have a negative exponent. So what we have to do is move that downstairs to make it positive. And this x to the 16th power is happy upstairs, so we leave it upstairs. And then again, we just have to figure out what 5 to the 4th is. Well, luckily I've done it enough times. I know 5 to the 4th should be 625. So that's 625 on the bottom, and it's x to the 16th on top. Now, let's take a look at the last set here. For our coefficients, the numbers that are multiplying the variables here, okay, for our coefficients there, basically think of it as a division problem. Can I divide the top number by the bottom number and get a whole number? In this case, we cannot. So the next thing we do is, well, can we simplify it? Can we think of it as a fraction? 3/4. Can I simplify that more? And we cannot. So we leave it sit exactly where it's at. So that's done no matter what. The 3 staying up top, the 4 staying down below. Now, for this part right here, p to the 2nd over p to the -4th. There's all sorts of different ways that we can do this. This p to the -4th is not happy, so you can move it upstairs. And that would then become p to the 4th up there, and it's positive. We have 6 p's up there, so it would be p to the 6th. That's one way we can do it. Let's see. Let's come over here. Let's put a 1 in front of this. Can I take 1 and divide it by 4? Nope. We'd get 0.25. We don't get a whole number there. So can we simplify 1/4? Nope. So we'll just leave it as 1/4. Now, what's going to happen here, since n to the second is happy upstairs, that's the same as if we had 2 n's up there. And since n to the fourth is happy downstairs, that's the same as if we had 4 n's down here. You'll remember that they can kind of fight each other. And we're left with the 2 n's on the bottom. So really, we're left with 1/4 n to the, again, there's 2 n's into the second. Last 3 problems right here. Finally, right here, even though we can't divide, we don't get a whole number there. 2 divided by 6 would get us 0.3 repeating. We can simplify the 2/6 to equal 1/3. So that's what I'm going to write. And we'll just let those numbers sit there. And then think about it. We've got 3 n's on top, 2 n's on bottom. They're going to fight. We have 1 n left right there. So there we go. Alternatively, you could see it written like this, n over 3. 8/3, there's nothing we can do with it, so it's just going to be sitting right there. Can't divide it, can't simplify it. The b's are literally going to cancel each other out. There's not going to be a single b left over. So 8/3 is what we have left. 5/6, can't divide it, can't simplify it, so it's going to sit right there. Remember, this x right here is the same as having x to the first, so it's 1x on the bottom, 3x's on top. It would simplify down to x to the second power.